Okay, when we talked about rationalizing denominators when we were dealing with the square roots, we talked about that. Instead of really talking about division, we talked about multiplying by the conjugate in order to get that radical out of the denominator. Well, interestingly enough, because when we're talking about complex numbers, we're really talking about the square root of negatives. So, in a long roundabout way, that's exactly what we're doing. So, the rules that apply to the radicals will also apply to the complex numbers. And just like in the radicals, when we were rationalizing denominators, we said if we had 5 plus the square root of 3, then we had to multiply by 5 minus the square root of 3. Remember talking about that? And we called those conjugates. Well, with the complex numbers, we also have conjugates. If you have your first imaginary or complex number is a plus bi, then its conjugate would be a minus bi. It's just where the imaginary part changes signs, and that's all. Okay, so here let's look through an example. Here we have a problem that says find the product of 4 plus 3i and its conjugate of 4 minus 3i. So these are conjugates of each other. Can you see that it is only the imaginary part that has changed signs? Okay, let's go ahead and do that multiplication. So 4 plus 3i and 4 minus 3i. Now, see again, this goes back. Everything works together. This is going back to factoring, because this is actually a difference of two squares. It's very interesting the way that this works. So if I were to multiply this, not even using anything fancy, just what we've been doing all along, we would have to distribute our 4 to get 4 times 4 is 16, and 4 times negative 3i would be negative 12i. And then we're going to distribute our 3i to everything behind it in the parentheses. So 3i times 4 would be a positive 12i. And 3i times negative 3i would be negative 9i squared. Okay, now I know that at some point you were itching to do something, but just relax. Wait till we get everything distributed through, and then we'll go back and we'll clean some stuff up. Now, looking at what we have now, it looks like we have a negative 12i and a positive 12i. Those will cancel each other out. And another thing is we have an I squared here. I squared is really times negative 1 instead of I squared. So this negative 9 times negative 1, this is the same thing now as saying 16 plus 9. Because negative 9 times negative 1 is a positive 9. And 16 plus 9 is actually 25. Very interesting.